Hi folks, this is Mrs. Lindsay again with part 2 of the scatterplot slideshow. Turn to slide 8 please in your scatterplot slideshow, and we'll talk about how we can find the equation of the line of best fit, or the trend line. Just like we typed data into the calculator for one list and found the mean, the median, and the quartiles, etc., we can type 2 lists of data into the calculator by opening up Stat Edit, typing the ice cream or the temperature in list 1 and the ice cream sales in list 2. Make sure you type carefully. The lists must match. If you miss any data, it'll give you an error and you'll have to do it all over again. After you do that, you will go to Stat Calc, but instead of hitting one variable statistics, since we have 2 lists and we're looking to try to find the trend line, we're going to go to number 4. So we're going to go to Stat Calc number 4, and that is going to give us the linear regression, the line. That's what we want. A is the slope, B is the y-intercept. I've decided to round those to the nearest thousandth, just to be super accurate. Typically, you can round them to the tenths or the hundredths. And then after I did that, I typed them into my y equals so that I could see the line. Now, the next step, you would like to see the line appear with the data for the scatter plot. So in order to do that, we need to turn on the stat plot to get the calculator to graph it. The stat plot can be found using these 2 buttons, second y equals. So if you go to second y equals, you'll get to the stat plot menu. Yours is probably turned off, so all you need to do is hit enter and then make sure it's turned on from this menu. You're going to see many different types of graphs here, and ironically one of them is the box plot, which we did a few days ago. But we don't want that because we have 2 lists of data, so we want the first one, which is already highlighted for you, the scatter plot. So once you have that, and everything's in list 1 and list 2, just where we want it, you want to get the calculator to graph this for you. So right now your calculator's window is set up to graph on an XY axis, so we need it to be set up to graph statistics. So if you go to the zoom button, which is right gray button in the middle of your calculator, you'll find this menu. Number 9 is called Zoom Stat. So scroll down to number 9 and hit enter, and then out will pop your scatter plot with your trend line. If you want to go to the table, you can find any amount of sales you want given any temperature. Okay, this looks to me like it's a positive correlation, and it does look pretty strong because many of those dots are very close to the line. It doesn't look perfect, but it looks pretty strong. So if I was to guess, I would say that this is strong positive. But what if you don't want to guess? If you're taking a test, I wouldn't leave it to chance. The calculator can actually calculate the correlation for you, and that's called the correlation coefficient, and we use the letter R for the correlation coefficient. So the calculator will get that for you, as I said. But first, you need to turn on the stat diagnostics in your mode feature on the calculator. Typically, you'll only have to do this once, so let's do it right now. Go to the mode button, which is next to the blue one, and you'll see this menu. Down towards the bottom will be stat diagnostics. You'll need that to be turned on. Right now, it's probably off. So use this right arrow key, make sure it's on, and hit enter. And then go back to Stat Calc number 4 again, and this time, in addition to the slope and the y-intercept, we see the correlation coefficient R. So what I'm going to do is round that to the nearest thousandth, because I like to be super accurate. And again, it'll probably tell you what to round it to. So my correlation coefficient is 0.958, rounded to the thousandth. Now, the closer your correlation coefficient is to 1, the stronger it is positive. The closer it is to -1, the stronger it is negative. So you can see I was right. This is strongly positive. So we have a scale. The correlation coefficient is going to be perfect if it's at 1. And you can see an example here. If I draw a trend line through that, you can see if I hadn't missed, all those dots would touch the line. But it doesn't have to be perfect. All these dots don't touch the line, but they all come pretty close. So it's not a perfect 1, but it's a 0.9. So we call these strong, anything between 1 and 0.9. We call them strongly positive. If it's between 0.5 and 0, we call it weak. Anything else is moderate. The same thing on the negative side. If it's 0, there'll be no correlation, absolutely nothing to do with each other. It'll be a jumbled mess. But it'll be a low correlation if it's anywhere between -0.5 and 0. That would be weak. And it would be strong if it would be negative between -0.9 and -1. So here, if we look at the scatter plots, the first one is definitely positive, but if I draw a trend line, those dots don't come all that close. I would say that's closer to 0.5. This one in number 2 looks a little bit stronger on the negative side. The dots are a little bit closer to the trend line, so I would call that a 0.9. Oops, that's 0.9. And on the third one, those dots don't look like they have anything to do with each other. I would call that a 0. Now, we have some scenarios here. To decide if we have a positive or negative or no correlation, I use the arrow method. So I'm looking at the number 4, the first scenario, the distance a person runs. I'm going to put an up arrow. This person runs a long distance. And how physically tired that person is. Well, as that person is running, they get physically tired. 2 up arrows, both things increasing at once, give me a positive correlation. That would be graph 3. Number 5, the price of a new car. Well, I'll give that an up arrow. The price of a new car goes up. Ooh, the number of hours in a day, that's not going to change. It's not going to go up or down no matter what. There's always 24 hours to a day. That looks like that would be graph 4. Number 6, a person's age. Well, as a person's age goes up, the amount of broccoli they eat, I'm not really sure about that. You can't tell from a person's age how much broccoli they're going to eat. That would be graph 2. And number 7, the number of cats in a barn. As the number of cats goes up, the number of mice go down because they run away. That would be a negative correlation. I would call that graph 1. Try the next slide with your calculator and check the answers on the last slide. The Northern Hemisphere cities and average temps. Any questions? Pop me up and I'll see you online.